Hello, everyone. Thanks for joining our KubeEdge deep dive. Unfortunately, a few of my co-speakers are not able to attend, so we just have two here. I'm Kevin Huan. I have multiple roles in the community, but today in this talk I'm presenting as the technical steering committee member of KubeEdge.
Hello, everybody. I'm Hongbing. I'm also a TSC member of the KubeEdge. So firstly, congratulations to Kevin, because in this keynote this morning, Kevin gets a very big achievement. He got a lifelong achievement for Kubernetes CNCF. So congratulations. Yeah.
Thank you. Thank you. Yeah. So just let's dive into the KubeEdge project. I will be quick in the general part, but hopefully we can maybe have more time on the details. So KubeEdge just moved to the graduation in the end of last year. So I think we only share a few times at KubeCon North America, so it's worth mentioning. But I like to highlight that actually, starting from 2018, KubeEdge has been working on quite a lot of interesting things. You know that typically, or most of the Kubernetes relevant work within the data center and or in the cloud, right? But the goal of this project is trying to, move out of the data center, trying to help the kind of workload better running on any part of the locations in the physical world. So as you might see that one of the biggest adoption in 2020 is the on the highway electronic tolling system, which have many servers on the edge node, and we kept working on a lot of interesting things, and I'm going to skip some of them. But in 2021, there was the first adoption, I believe, that's in the world. We successfully deployed KubeEdge on a smart vehicle to help manage the containerized application on the vehicle. So I think that's the first cloud-native car, and also in the same year, the first one running on top of a low Earth orbit satellite. So it's we are really expanding the location of the workload to make it able to manage the workload on top of the satellite. To you can trigger remote upgrade, and you can do some like on satellite computing to help save the bandwidth between cloud and satellite and the ground. Yeah, basically extend the life cycle of the battery. Yeah. So yeah, we have been working on a lot of things, so I'm not going to the details. So just the introduction about this project, why we started working on. Back to 2018, there was a lot of interesting thing happening on, and we think that it's really valuable, to use cloud-native technology to help manage the workloads on the edge. We know that there are kind of multiple different kind of type of the edge, but some of the shared challenges were like the resources were really limited. We need to be kind of very tight, lightweight, and also the connection between basically the control plane or data center to the edge is very unstable, with high package loss rate, with high network latency. So we need to kind of really think about how to save the bandwidth, save the network requirement. Yeah. And also the edge servers, and also there are a lot of kind of sensors all in the different hardware architecture on the edge. So we need to, we want to kind of bring a unified abstraction on top of that, because we know that cloud-native technologies tend to be hardware agnostic, right? And also the abstraction of application defined by the declarative API, it was very good practice. So it really should benefit a lot, not just for the workloads inside the data center. Yeah, a little bit details to the KubeEdge architecture. The way we choose was to put the node on the edge, not the whole cluster, because that would require a larger footprint. And with this architecture, it helps you to achieve the collaboration between whether it's a cloud or it's a data center control plane. And also maybe you have nodes in the control plane or in the data center or in the cloud, and as well as you have remote nodes on the edge, and you can trigger development testing in the data center, in the cloud, and then do your production deployment onto the real edge with just the same set of API abstraction. Yeah. The network communication between the control plane and the edge nodes, we basically kind of hooked the connection between API server and the node. So the underlying protocol was implemented initially by WebSocket, and later on we also brought support with Quick. So it's like really kind of shadow management. So you can still have all the API objects updating in the API server, but the real implementation, like the actions of the edge nodes and the pods on the edge are done by the edge core. And we just released a new version of KubeEdge, and with a bunch of improvement, but I will not go into the details. So I would just recommend you to take a look at our changelog. We do kind of always work hard on writing our changelog to motivate people upgrade. Yeah. So this is the we have kind of organizing our community work also by SIGs. It's kind of similar idea to Kubernetes. So for the SIG node in KubeEdge, it focuses on basically the node management. We know that it's a remote node, so it's like a little bit not that easy when you compare it to your management to the nodes in the data center in the same Kubernetes cluster within a set of certain racks. So we improved the image downloading and also like automatic restarting for the edge modules. So make adopters easier to trigger remote kind of maintenance or remote upgrading for your the nodes on the edge. So and we know that actually for the adopters of KubeEdge, quite interesting thing is that with some of the most of the adopters, they have kind of nodes located in different areas. So it's not just possible to send people to all that locations to do manual upgrade. So relate kind of upgrading, relate maintenance is truly useful to help save our daily life. Yeah. Another thing is we call it device IoT. It's more relevant to IoT scenarios, but the idea is we really want to simplify the management for the IoT devices, or for the we call it maybe lift devices. We want to bring some of the abstraction to kind of better isolate the control plane, basically the lifecycle management for the devices itself, as well as fetching, data from the devices, and we know that it's quite useful to kind of do some of the filtering or comparison of the data to reduce and figure out the most valuable part for the applications to consume. Yeah, that's the idea. We also have been working on this the interface we call it DMI, the device management interface, for quite a couple of times. So just with this latest release, we introduced the support with C language and sorry, I don't remember the other language. So basically, most of the popular language, you are able to kind of easily develop your own device plugin for the IoT device, not for the node resources. And another challenge is about the network between the edge nodes. So in many of the case, the nodes, the network on the edge nodes tend to be kind of isolated. So your nodes may be located in different LAN. So KubeEdge for control plan, we implemented automatic kind of tunneling to help it going through the LAN, but we also want to provide this flexibility for the applications. So the sub project named Edge Mesh is kind of to focusing on this. So we implemented with the P2P tunneling to help build the connection between edge nodes to enable the workload discovery, workload traffic communication between each other. And we also implemented with a node local DNS resolution to make it able to work even it's disconnected to the control plane. And also it's exposing the same user experience, developer experience, just as vanilla Kubernetes. So you don't need to have any extra configuration. Once the edge mesh is there and your pod going to the edge node, it will just hook your traffic and send it to the terminal to the right edge node. Another topic might relevant to AI, but actually KubeEdge has been working on AI for quite a period of time. So we know that the resources on the edge is always limited, but the location is very important because it's always close to either data producer or data consumer. And in a lot of cases, maybe consumer and the producer are also located very closely. So that's why we incubated the sub-project called Sedna. We provided a few types of the patterns for inferencing and also for learning. Yeah. So one of the patterns is called the joint inference. So actually there are, even today, not with LLM, but there are still a lot of inference just to require very little resource with, and they don't have kind of very high requirement for the result. So we can have very kind of small part of the inference running on the edge node, and with some of hooking provided by the Sedna, if the result is not that good, automatically fall back to the cloud part to kind of retry. Yeah, so that's for the joint inference. And also for training, it was popular a few years ago, like federated learning. But today, I would say it's still very valuable because you can use that to kind of trigger some of the pre-processing of your raw data. And also, it saves the bandwidth between your edge and the data center or in the cloud. Another very interesting thing is about the robotics. Yeah, it's more like a very interesting adoption period of part. So KubeEdge started working on it, but still working on it. The idea was trying to simplify the robotics relevant development. So we have been started working on a few of the demo use cases and also proof of the concept. And also recently we are trying to maybe have more deeper collaboration with the ROS community to achieve like robot fleet management sort of thing. Yeah. All right. Next, we will introduce some of the case studies. So I will hand it over to Hongbing.
Okay, thanks, Kevin, for the elaborate technical discussion. So you can see that for the KubeEdge as a first cloud-native edge computing system, it's gracefully extended the Kubernetes from the data center to the edge side, right? But as not just a new project, how can we get KubeEdge graduated? It's not just for the technical. I think the 2 points are very important. So number one is we have quite a few end users, many use cases. And number two is we have a very consistent, sustainable, transparent governance model. So first, let me introduce some typical case studies to you. Unlike Kubernetes, which is running majority in the data center, but KubeEdge will embrace many typical and many various edge scenarios. So our customer cover all kinds of the traditional industries as well as many newly AI areas. So from the PPT, you can see that we have a big range of the customer sectors from intelligent transportation, energy, industrial factories, and CDM, vehicle, right? Even satellite. Many of you heard about the satellite case, right? And the financial, banking, logistics, and other, the AI accelerators. So this is a big range of the end user, right? So I will not talk one by one. I just select a few typical cases to you. The first one is smart retail. Unlike the traditional retail, its usage is many go to a store and buy something, right? So right now, smart retail has a lot of devices equipped in the store, and a lot of data will captured and transferred back to the data center for calculation. Imagine one use case. When you go to one store, all your footprint will be captured, and the data will calculate something you like or something you don't like. So this data will transfer and analyzed by the data center. So this is the use case. Actually, this is a very big, world-famous store. It has more than maybe 10,000 stores worldwide. So we use KubeEdge to design one value-add scenario for this store. The scenario is quite simple. When a customer goes to a store, and maybe you are stopped at a shelf, and you look something. For example, maybe you are interested with one bag of food. So maybe you stop for a few seconds. So the camera and the sensor will sense that maybe you have interest for this bag of food. That means there is a screen in front of you. So the screen will automatically give you a video of introduction of this bag of food. So for this case, this is a very value add. It's also a very profitable scenario for the store. But the requirement is there is 10,000 of stores. How to manage this big amount of stores? How to upgrade? How to deploy application? How to communicating the data between the store and the data center? So all the solution will be based by the KubeEdge. So by install cameras at a appropriate location in the store, which can monitor the foot traffic for the advanced screen. right? And for the beneficial, the high efficiency and the low computing. This will compute and the business capabilities all are decentralized, leading to fast response and low coupling. In complex network environment, for example, when the network is unstable or the network is broken, so all the applications, all the solutions in the edge side can be autonomous. They can run by themselves. When the network is come back, so all the data will resume the data communication between the edge and the data center. So as a result, for the operational and the maintenance, so this will be much easier. Comparing to traditional operation and maintenance, it's quite difficult. So when your application needs to be upgraded, so a lot of efforts will be put to do that. With the KubeEdge, because KubeEdge will make the data center experience the same as the edge experience by using Kubernetes, by using the container, by using the CI/CD and the microservices. So this is a typical scenario for the smart retail. So the next one, which Kevin introduced, because this is also a typical use case for KubeEdge. In China, KubeEdge enables and powers the express highway. In China, a lot of express tolling gate, right? Maybe more than 10,000 for the whole country. I'm not sure about the US, right? So this will have a big challenge, right? The first challenge is every toll gate, they have a different computing architecture, maybe x86, or maybe ARM, maybe other, maybe portable devices. So this is a heterogeneous device management, right? So the next one is, for all the user experience should be with no latency. When a car drives through the toll gate, it should be responded very quickly, right? Instead of waiting some time. So it needs a very low latency. And also, last but not least, unified management. When the system should be upgraded, or the application need to be upgraded, should be one button click. So the data center maybe send one command to all the edge loads. It will finish all the upgrade very quickly, right? So this is also a very typical case. For the user value, so edge and the cloud collaborative architecture allows for flexible expansion of all solutions with a single network for the national express system. Also, we effectively improve the efficiency nearly 10 times, reduce the passenger time for each vehicle to only 2 seconds. So this is also a very useful and influential use case. So the last one I need to share is about robots. So right now, robots is very hot, right? And also how we can manage the robot with a group of robots. So this is a question. And for the group of this is a scenario with a group of robots, right? But for the robot itself, it's hard for itself to complete a natural language. So NLP with large language model should be running on the data center, on the cloud, right? But the cloud, all the data, all the information will be collaborative within the cloud and the edge. We have a warehouse to be the edge server. It will predict the flow and the control tasks, right? And collaborate with the cloud. Also, it will give commands to the group of robots, right? So the robots will receive the command from the edge node, but this node should be fully connecting with the cloud side. So this is also a cloud and edge scenario, which is used in the robots sector. Okay, so besides the tremendous end user, a transparent or sustainable governance model is very critical if you want your project get graduated by CNCF, right? So only 10% of all the projects of CNCF get graduated. I think the majority of the issue is not just for the technical, it's mainly about the governance. How to ensure your project be sustainable It will not depend on one people, a small group of people. So this is important. So let me share some ideas about how to build a thriving community. The first one is but I think the most important is your governance model should be transparent and sustainable. So for KubeEdge, we spend a lot of time to build a transparent and distributed governance model. So here is our governance model. We have a TSC Technical Steering Committee, which is, I think, is a headquarters and the decision group of all the KubeEdge projects. And we have a subcommittee and special teams, right? Also, we have SIG, special interest groups with some sub-projects. And we have a regular meeting to discuss many important things or technical, operational governance. Next, we have broader partnership across the industry, academia, and the research, right? We have many professors join us. We have many students. We have many researchers to join us. Of course, the end user for industry is very, very important. So this will make a closed loop. We are not just the one-way direction. We will not just release our technical projects, but we are receiving many feedbacks and many inputs from the industry. So this is a partnership with the whole ecosystem. So next, we are collaborating with different organizations, maybe CNCF and maybe other edge projects of other foundations, right? And we have launched quite a few mentorship programs under CNCF. So right now, for past 10 years, we provided more than 30 KubeEdge-related projects to train our potential contributor. Also, we have continuous communication and development with the community. Right? We have regular meetups. We have some end-user sharing. Also, we are joining quite a few influential conferences, right, to get more attention from the industry, from the developers, from the potential end user. Right? How to connect and grow our developer? Yeah, we have a set of the rules and a set of experience. For example, the developer guide, community roles, and the contributor lessons, and the communication mechanism. So I think our goal of KubeEdge is make cloud native ubiquitous. It's because we can run every traditional sectors, right? So our architecture is we can make the data center experience as consistent as the edge side. So we can make cloud native ubiquitous run everywhere. So these are some links and from website for you to check and follow. We have a GitHub, right? We have a Slack. Welcome anybody to join us. Okay, thank you. So any questions?
There's a microphone there, so if you have any question, please feel free to ask. Sorry? You mean flat? So what the? Yeah, that's a very good question. So just let me repeat. The question was how to kind of set up the nodes at a scale, right? So that one, currently we don't yet maintain the tools in the community yet, but a lot of downstream adopters, they have their kind of own tool to basically remote access to the node server. That's the kind of the first time. But after that, with KubeEdge there, you can able to always trigger with KubeEdge, because even you want to kind of upgrade some of the package on the operating system, KubeEdge is able to trigger a script running on that node. And we also implemented the automatic recovery, even the script runs into any error, and we will just roll back to the previous version. Yeah.
So, a couple quick questions, I hope. Sorry if they're stupid, but like, how small of a footprint can you get KubeEdge down to for edge devices? And since we're looking at edge devices that may be connected to important things, what is the attack surface like, and how does that compare with, security, if, assuming it's physically secure, to like K3S or K0S that have more of a full stack implementation at the edge?
Yeah, that's a very good question. So for the footprint, we typically calculate like this. So it actually also depends on the workload you are trying to run on KubeEdge. But KubeEdge itself, the node component takes only, I remember, 128 megabytes. And also, you may need to reserve at least 100 megabytes for the operating system. Yeah. And another one is about the runtime. If you pick like CRIO, it's down. It can be down to 30 megabytes. So basically, if you have 512 megabytes, that's kind of very sufficient for all the control plane, still control plane components, right? And the rest you can just save it for workload. Yeah.
Yeah, I can give you a few more comments about this question. So maybe some of you are using other edge systems like K3S, right? Unlike K3S, KubeEdge has lightweight architecture. Yeah, because it focuses on the collaboration between edge and the cloud. So our target is not build an edge Kubernetes system, but it's an extension of the data center. So this architecture enables the edge side will be very lightweight. Okay.
Yeah, I just want to finish the answer to the previous question. So considering the security, so you don't need to kind of expose any ports on the edge node. Even it's inside a LAN, that's okay. If you are running your control plane on the cloud, you can just expose the IP address of the cloud core. So basically, that's the kind of where edge nodes register, kind of build the bi-directional connection. And yeah, that's it. And everything will sync in both directions automatically. Yeah. Yeah, please. Oh, yeah, let me just repeat the question. So the question was, do we have Kubernetes running on the edge node, right? On the edge core. So edge core is, you can typically think it's a node, but with additional parts. So a node means that there's a lightweight kubelet inside it. We removed a few redundant features, but the kind of all history of the modification to the vanilla Kubernetes is on the GitHub, so you can track everything. And even you want to kind of add a few more things back, or you want to remove more features, that's kind of totally reproducible by yourself. And the additional functionality is about dealing connection between cloud and edge, because it's like automatically register to the cloud core and build the bi-directional connection. And also to implement the node local autonomy, we make it able to, even if the connection is totally down, the node is able to recover from disaster by itself. No need to wait a connection to the API server. So that's unique to the vanilla Kubernetes. Another thing is that actually, because we have a local metadata persistency, if the kind of the version ID is out of date, it's still, it's always trying to sync with only diff. There's totally no rewatch. So that means that the network is very kind of, and the traffic will be very stable. There's no kind of peak caused by any released between the node and the API server. Yeah.
Okay, maybe it's over time. If any other questions, we can talk offline. Thank you.